Okay, let's then go to the next topic. How can we compare two fractions? You're given two fractions and you need to compare them. We have three cases that we're going to go through about comparing fractions. The simple case would be when you are comparing two fractions with the same denominator. Let's read the question and try to make sense of how can we compare the fractions. Would you rather having 1/10 of a cake or 3/10 of the same cake? Let's assume that you want to have the more portion, the larger portion. Which one is larger? Which one you're going to pick for yourself? The 1/10 or 3/10? Well, I mean, even if you do not know fractions, it's just a common sense to pick 3/10 because that in our mind means that we have two cakes the same size. We cut each of them to 10 equal pieces, and in your mind you will compare 1 of the 10 or 3 of the 10. So 3 of the 10 would be the greater fraction. But the way you also want to think about it is if you have the denominators the same, compare the numerators. The one with the greater numerator is the greater fraction. So we can write 3/10 is greater than 1/10. Or I can state that a different way, saying that 1/10 is less than 3/10. And in this case, I'm going to pick the larger portion if I'd like to have more sweets. So that is simple. Let's look at another case, number 2, when you have to compare two fractions, but they do not have the same denominator. I cannot do, 9 greater than 5, then 9/14 is the greater or larger portion. We cannot do that. You may be right. Maybe the answer is going to be at the end that 9/14 is larger, but this is not the right method. It's not going to work on every two fractions that you have with different denominators. So what should we do? Would you rather having 9/14 of a pi or 5/7 of the same pi? Using just imagination, we cannot really tell which one is bigger. So the only way to do that is to change the two fractions to equal fractions with the same denominator. Now, I know that one has a 14 and the other one has a 7. I know that 14 is a multiple of 7. 7 times a number will give me a 14. So in my mind, I can change 5/7 to an equal fraction with a 14 in the denominator the same way we have been doing. So I'm going to do 5/7, and then I'm going to multiply that times 2 and times 2. And why did I pick 2? Because 7 times 2 will give me 14, and 14 is the same denominator as the other fraction. So that way I'm able again to compare the numerators and decide which one is larger or which one is smaller. 7 times 2 is 14, and 5 times 2 is 10. So this fraction is equivalent to 10/14. So the first fraction says 9/14. The second one is 10/14. Which one is larger? The 10/14, because our method says now if the two fractions have the same denominator, would they have, then compare the numerators. The one with the larger numerator would be the larger fraction. So that way we are able to say that 9/14 is less than 10/14, or just to go back to the original fractions, we can say 9/14 is less than 5/7. And if you want more pi, you will then pick the 5/7 option. If you want less, then you're going to go with the 9/14. Okay, let's go back to the same topic, case number 3. We're still comparing fractions. This time, the fractions that you see on the screen, they have different denominators, but the same numerator. So in that case, we have another rule that we go by. Let's read the question. Would you rather having 4/6 of a pizza or 4 over 15 of the same pizza. Let's try to make sense of the fractions and see if that would help us decide which portion would be larger. If you have two pizzas the same size, you cut one into 6 pieces and the other one into 15 pieces. So the one was cut into 6 pieces will have bigger pieces, larger pieces, but the one that was cut into 15 pieces, each piece is tiny. Would you then rather to have 4 large pieces, 4 over 6, or 4 tiny pieces, 4 over 15? What do you think? Which fraction would allow for more portion? And the answer would be the 4 over 6 because you're going to get 4 large pieces. So what's the rule behind it? The rule behind it is when you have two fractions, have different denominators but the same numerator, the fraction with the smaller denominator will be the fraction of the larger value. So in that case, I'm able to right away say that 4 over 6 is greater than 4 over 15. So if you want more pizza, you're going to go with the option number 1. Less pizza, then you're going to go with option number 2. Okay, let's move on then to the next slide. We're still going to compare fractions, but we're going to have these kind of problems. Number A, 5 over 16 is what to 17 over 32? We're supposed to use either the greater than, less than, or equal sign to make those statements true. So we're going to do the same thing. We are going to do the comparison. We're going to decide which case is that. We have two fractions for number A. Two fractions, they have different denominators, different numerators. Then that is case number 2. Case number 2. What should we do to compare these two fractions and use one of those symbols? I'm going to look at the denominators, 32 and 16. With my knowledge of the multiplication table, I know that 32 is a multiple of 16. 16 times a number will give me 32. What is that number? 2 times 2 and times 2. Then I'm changing the first fraction to an equal fraction with a 32 in the denominator. So I'm able to use the case number 1 to compare only the numerators. So 5 times 2 is 10 over 32. I'm comparing that with the 17 over 32. Again, I did not change the second fraction because it already had the 32 in the denominator. In this case, I have two fractions. They have the same denominators. Compare the numerators. Then I'm able to write the right sign for the fractions. 10 is less than 17, then the first fraction is less than the second fraction. And I'm able then to say that 5 over 16 is less than 17 over 32. Question B, 6 over 11 and 6 over 21. This is case number 3, where we had the same numerators and different denominators. So that is case number 3. And if you remember the pizza example, these are 6 large pieces and these are 6 tiny pieces. So we compare the denominators. The one that has the smaller denominator is the fraction with the larger value. So in that case, we would put the sign greater than in between the fractions. Number C, 5 over 14 and 9 over 14, that is case number 1, straightforward. Compare the numerators since the denominators are the same. 5 over 14, 9 over 14, the 9 is greater. Then I can say, well, 5 over 14 is less than 9 over 14. Number D, 45 over 45 is what to a 1? We know that a part of a whole, if the part on the top the same as the whole, that means I'm gonna eat the whole pizza. If I cut my pizza to 6 pieces and I eat all 6 pieces, 6 over 6 is 1. So that would be equal to 1. Okay, let's go to a self-check question on the same topic, comparing fractions. We have 6 over 25 is what to 16 over 75? You can write down the question. Take your time looking at the which case is that question, case number 1, 2, or 3. If it's case number 2, which is a little bit harder than the other two cases, you want to compare the denominators and determine if you have to use a factor to change one of the fractions to an equal fraction. So again, it's case number 2. The denominators are different, the numerators are different. Then I'm going to think about 75 and 25. Well, I know that 75 is a multiple of 25. 25 times what will give you 75? If you're not sure, you can use a calculator. But really, if you think about the quarter with a dollar, you know that 3/4 will give you 75 cents. So you know that 3 times 25 will give you 75. Do the same thing on the top. That will give you 18 over 75. Compare that with the original fraction, 16 over 75. Now compare the fractions, same denominators, compare the numerators. 18 is greater than the fraction itself is also greater. So the answer is A.